Hello and welcome back to Maths with Mr. Duffield. I am the aforementioned Mr. Duffield, and what I've got in front of me is the last question on the parallel and perpendicular lines exercise that my Ellie have been going through in the last few days. Now, it's a bit of a humdinger really, because I've been given two lines, and line one has been given an equation, so obviously relates to this upward sloping one. But it immediately asks me to find the equation of line 2, and there aren't any numbers on this grid, so I can't really make sense of it, or at least not until I start using what I know about this equation to label this scaling. Here, let me talk to you about what I mean by that. Let me just turn the page over. So y equals 3 over 2x minus 24. Let's write that down. We can just use this line equation to immediately find where the graph intersects with the x-axis and the y-axis. We can find the y-axis intercept by finding, well, the answer to the question, well, if x equals 0, what's y? And we can find that by replacing x with 0 here. 3 over 2 times 0 is 0, so y will equal negative 24. In other words, one coordinate that satisfies this line is 0 minus 24. 0 along the corridor, 24 down the stairs. So this point here is minus 24. Okay? We're going to do the same thing, a very similar thing, sorry, to find the x-intercept, except we're going to do the opposite. We'll say, if y equals 0, what's x? Well, let's replace this in. It's going to be a bit more complicated this time around because it doesn't immediately give you x on its own. Replacing y with 0 will give you 0 equals 3 over 2x minus 24. Okay? Isolating x means solving. Adding 24 to both sides seems a good place to start because we want to get x on its own. That negative 24 disappears, and I'm left with 24 on the left and 3 over 2x on the right. Remember, x on its own, not 3 over 2x. So let's get rid of that division by timesing both sides by 2. Fractions make me nervous, you know that about me. 24 times 2 is 48, equals 3 over 2x has been cancelled out to make 3x by that times 2. Dividing both sides by 3 is the last little stage. So, 48 divided by 3. 16. 16. So, another coordinate that satisfies this equation, this straight line equation, is 16, 0. 16 across and 0 up or down, which means that this point of intersection here on the x-axis is 16. Okay? Now, I've added it to the grid because, well, we need to bear in mind that this has been drawn with grid squares, which means it's accurate. What do I mean by that? What's Duffield talking about? It means every square on the y-axis is worth something consistent, and every square on the x-axis is worth an equivalent amount. Okay, so let's look at the y. 1, 2, 3, 4 down is minus 24. Okay? Now, what is each jump worth? 4 jumps taking us to minus 24. Each jump has got to be minus 6. Minus 6, then minus 12, then minus 18, then minus 24. Upwards from 0, the jump has got to be positive 6, which means that here the y-axis intercept for line 2 is 12. Let's look on the x-axis. 1, 2, 3, 4, 5, 6, 7, 8 jumps to 16. So that means each has got to be worth 2, right? 2, 4, 6, 8, 10, 12, 14, 16. Another jump of 2 gets us to the x-intercept for line 2, 18. So what have we got here? We've got the y-intercept here, and we've got the x-intercept here. In other words, we have two coordinate points, don't we? 0, 12 and 18, 0. Now those two coordinates, they're good to know, aren't they? Because if I know two coordinates of any straight line, I can find its equation straight away, because I can find the gradient, change in y over change in x. 12 decreases to 0. X increases to 18. Okay, so that's the gradient. Can I simplify that? Of course I can. 12 divided by 3 makes 4. 18 divided by 3 makes 6. Oh, they divide by 6, don't they? I'm being very silly. Minus 2 over 3. Minus 2 over 3 is the gradient. So y equals negative 2 over 3x plus c. That's y equals mx plus c, isn't it? So the gradient is minus 2 over 3. And what's the plus c at the end? Well, actually, we don't need to do anything. We can see where the y-intercept is right here. Remember, the plus c at the end of every line equation is the y-intercept. So that we can just immediately replace that with plus 12. This is the equation of line 2. Y equals negative 2 over 3x plus 12. Now, are these lines perpendicular? Good question. How do we check? Let's take a look. Take the gradient of line 1. Line 1m is 3 over 2. And the line 2m gradient is, we worked it out, minus 2 over 3. Let's times them together, see what we get. If it is perpendicular, we expect them to multiply together to make something specific. Probably already know what it is, don't you? That becomes minus 6 over 6, or minus 1. If two gradients multiply together to make negative 1, they are perpendicular. So m1 times m2 equals negative 1, therefore lines 1 and 2 are, it's the worst written E in the world, perpendicular. That's it. We've done the question. We've worked from the accurate drawing that we have on our graph here to work out points on the graph and therefore the equation of line 2. And then we've worked using those two gradients that we found, proving that they're perpendicular because they multiply together to make negative 1. Absolutely brilliant. Awesome stuff. Well done for paying attention. I encourage you to keep on going with your work, and for goodness sake, get your work uploaded to Teams. I will talk to you very soon.